All right, folks, the next part of the notes deals with pH calculations and pOH calculations. So that's what we're going to dive into right now. Before we get too far into this, though, I need to explain something that water does, and it's a process called self-ionization. And what self-ionization is, basically, we have this equation with water where I've got H2O as a liquid, and some of that H2O is going to lose a proton and is going to donate it to the other H2O that's available. So what we end up with actually is a hydronium ion and a hydroxide ion that was made solely from some water molecules losing its proton and giving it to others. Okay, that's what I mean by the self-ionization of water. Okay, we can represent this with this equation right here, H plus times OH minus, and anytime we see these brackets, that means concentration. So the concentration of H plus times the concentration of OH minus equals 1 times 10 to the negative 14th power. Okay, we're going to be able to use this in an equation while we're calculating pH and pOH. So essentially, in terms of concentration, if I have a greater concentration of hydrogen ions than I do hydroxide ion concentrations, I know that I am dealing with an acid. If I have a greater concentration of hydroxide ions than I do hydronium ions, then I know I'm dealing with a base. And if both of those are perfectly even, if both of those concentrations are perfectly even, then I know that I have a neutral solution. So let's see how we can relate that to what we call the pH scale. The pH scale essentially is this scale that goes from 0 to 14 that measures the H plus concentration that's found in a solution. So if we have a really high H plus concentration, then we're going to end up with a really low pH, okay? So if we have a pH of 0 to 7, okay, basically 7 and below, that's going to give us an acidic solution. Anything greater than 7, 7 to 14, is going to give us a basic solution. And if it's perfectly right at 7, that's going to give us a neutral solution. So we can kind of take a look at this chart here. There's something called pOH as well. pOH is the exact opposite of pH, okay? And what that's measuring is it's measuring the hydroxide ion concentration that's found in a solution. So this is a pretty fun example right here dealing with two clear solutions placed in separate beakers. And it says one solution has a pH of 4 and the next one has a pH of 5. Excuse me, one has a pH of 4 and then we add something to it. We add an unknown to it and the pH goes up to 5. Well, if we started with a pH of 4, then I know that if I added something to it and it raised the pH, whatever I added to it must have been more basic, meaning it had a higher pH. It had more hydroxide ions, so then it raised the pH when I mixed it with an acid. This next question, if our pH has or excuse me, if our swimming pool has a pH value above 7.5, we should add an acid because we know acids have low pHs. If we add something that has a low pH, it's going to drop the pH of our pool down to 7.5, which is apparently where we want our pool. So let's go ahead and take a look at some of the calculations. This is something I like to call the pH square. And the pH square is a fun way to take a look at how we can use the calculations. Basically, if I have any one corner of this square, if I have pH, pOH, H plus concentration, or OH minus concentration, I can use this system of equations that can get me anywhere else around my pH square. Now I realize that my screen is kind of small, so well, I guess I can minimize here. There we go. So this gives you an opportunity now to look and see all of these equations. So if I have pH and I want to get to pOH, I'm going to use this top equation, which I feel like is the easiest one. pH plus pOH equals 14. Okay, remember this one earlier. We were talking about the self-ionization of water, and I gave you this equation. And then if I have H plus concentration or OH minus concentration and I want to get to the pH or the pOH, I can take the negative log of that concentration to get the pH, or the negative log of this concentration to get the OH minus or the pOH. Okay. If I have the pH and I want to find the H plus concentration, I'm going to do what's called the antilog. And the antilog, I'm going to hit my second key. Let me turn this on for a second, okay? I'm going to hit the second key, and then I'm going to hit log, and then I'm going to get that little 10 to the right there, okay? And that is going to, once I get the 10 to the, I can type in the negative pH, and then that'll get me my H plus concentration. So let's go ahead and take a look at a couple of examples, and then we will call it a day. So one moment real quick. So we have this example. It says if a hydrogen ion concentration in a water solution is known to be 4.3 times 10 to the negative 6 molar, what's the hydroxide ion concentration? Well, if I look back to my pH square, I see that if I have the H plus concentration times the OH minus concentration, I know that that should equal 1 times 10 to the negative 14th power. So what I can do is I can say, okay, I know that I'm looking for my H plus concentration. Remember, brackets means concentration. I know already. Actually, the H plus concentration is, that's what I'm looking, or that's what I already have. That is 4.3 times 10 to the negative 6 molar. I'm looking for the OH minus concentration, so all I have to do now is plug and chug. Okay, so I know that this times this equals 1 times 10 to the negative 14. So I'm going to do 4.3 times 10 to the negative 6, times my OH minus concentration equals 1 times 10 to the negative 14th power. And so when I type that on into my calculator, of course, I'm going to divide both sides by 4.3 times 10 to the negative 6. When I type that into my calculator, I should get 2.3 times 10 to the negative 9th for my hydroxide ion concentration. 2.3 times 10 to the negative 9. And the way I did that was I divided both sides by this value. So now it also wants to know, is this acidic or basic? Well, check this out. I don't have to solve for the pH in order to find that out. I just have to look and see which number is bigger. Well, anything times 10 to the negative 6th is larger than something that's times 10 to the negative 9. So therefore, since my H plus is larger, my H plus concentration is larger than my OH minus concentration, I know that it is acidic. So that's how we're going to take a look at these problems. So we're going to go ahead and take a look at another kind of problem as well, which is going to use a different portion of the pH square. So let's take a look at this problem dealing with pOH. It says the pOH of a solution is 5.6. What's the pH? I think these are the easy ones. Okay, we can use that top formula there on our pH square. And so if the pOH equals 5.6 and I'm looking for the pH, I know I can plug straight into that formula where pH plus pOH equals 14. So therefore, I'm looking for pH. pH plus 5.6 equals 14. So now all I have to do is subtract 5.6 from both sides. And when we subtract 5.6 from both sides, that should get us a pH of 8.4. So now it's asking if this is acidic or basic. Well, now I know that if I have a pH that's greater than 7, I know for a fact that it is basic. So that's how we solve these kinds of problems. We're going to do two more where we look at the left and the right hand sides of the pH square. This next one here, let me erase this for a moment, says if the pH of a solution is known to be 4.2, what is the hydrogen ion concentration? Well, on this one, I'm going to use the left-hand side of the square. I know that I have the pH of 4.2, so I'm going to do the anti-log on my calculator, which is where I hit second log, and that's going to give me a 10 to the. So now I'm going to do 10 to the negative 4.2. And I'm going to hit enter on my calculator, and when I do that, when I type that in on my calculator, 10 to the negative 4.2, I should get a value of 6.3 times 10 to the negative 5th power. So now this wants to know, is it acidic or basic? Well, once again, this is really easy because it gives me the pH of 4.2. If I have a pH less than 4.2, I automatically know that it is acidic. All right, we're going to do one more of these problems where we are going to start with the concentration. Let's do one where we start with the concentration of hydroxide so that we can use that right-hand side of the square as well. Do I have one like that? I don't. So we will go ahead and just do, um, we'll just do number 13 right here. So this one says it gives us our hydrogen ion concentration. So our hydrogen ion concentration is 5.5 times 10 to the negative 10th power. And so this is another plug and chug problem. I'm just going to take the negative log of this number. And so on my calculator then, I'm just going to type in negative log, okay, oh, not that. Okay, I hit negative log and I type in that number, 5.5 second E negative 10, hit enter, and I get that my pH then, my pH equals 9.3. So once again, it wants to know, is this acidic or basic? So I ask myself, is my pH greater than 7 or less than 7? Since it's a greater than 7, I know that this is a basic solution. So that's how these problems work. These are just plug and chug, so make sure you practice this in the homework, and I think you're going to do a great job. Thank you so much.